A mass of 3.5 kilograms is moving towards the right with a velocity of 7.7 meters per second when it collides with a second mass of 5.5 kilograms. After the collision, the second mass bounces off to the right of the original path of the motion of the first ball at an angle of 27.65 degrees with a speed of 5.16 meters per second. First bit. What will be the magnitude of the final velocity of the first mass after the collision? B bit. What will be the direction of motion of the first ball after the collision? C bit. How much energy was lost or gained in this collision? D bit. Was this collision elastic or inelastic? Explain your reasoning. Obviously, this question is based on collisions. Collision in 2 dimension. Here, two balls are there with different masses. First ball has mass of 3.5 kilograms. The second ball has 5.5 kilograms. This is 3.5 and this is 5.5. And then this ball is moving along the x-axis, positive x-axis, and then hits the second ball, which is at rest. After the collision, both the balls will move in two different directions, making different angles with the horizontal. And we have to find out what will be the velocities of these two balls or the masses. Okay. The masses are different and then the initial velocities are different. That means the first ball is moving with a velocity and then second ball is at rest. And then after the collision, both the balls are moving in two different directions with two different velocities. And we have to find out whether the collision is elastic or inelastic. Okay. And then moreover, we have to find out the final velocity of the first ball and also the direction. Okay. Now, we know the collisions are of two types, elastic collision and inelastic collision. Suppose if the collision is elastic, both the momentum and kinetic energy are conserved. And if the collision is inelastic, only momentum is conserved. So based on this, we will try to solve the problem. Okay. So whatever may be the collision, the momentum is conserved. Okay. So from the momentum aspect, we will try to find out the velocity and then the direction. Okay. Final velocity of the first ball and also the direction. So the data is given to us that I noted down here. And then we have, after the collision, the balls are moving two different directions, making some angle with the horizontal. Okay, that angles we have to find out. That means in two different directions. No, so we have to find out the direction also. So we have, this is a, we will have only two here. In your syllabus, you have only 2 dimension, not the 3 dimension. Therefore, we have x dimension and then y dimension. Okay. So first we will try to equate the x direction momentum before collision and after collision because momentum is conserved. So the momentum before collision is equal to momentum after collision. So here, first we will take the x direction and then later y direction and then we will try to find out the final velocity and also the direction. Okay. So let us see what it is. So here is the data and then we will write down the x direction momentum. So what is the x direction momentum? m1v1x plus m2v2x is equal to m1v1x dash plus m2v2x dash. Okay. So input the values here. The same, the values m1 is equal to 3.5 kilograms and then m2 is equal to 5.5 kilograms. And then V1 is given to us as 7.7 meters per second. And then V2 is equal to 0 because the second object is at rest. And then the final velocity of the first ball we have to find out. And then the final velocity of the second ball is given to us, x dimension and then y dimension we have because it is making an angle of 27.65 degrees. And then x dimension is cos 27.65 degrees. How? Because this is the adjacent side to the angle. So adjacent side is this one, a cos. Am I right? Opposite side is sine. So y dimension will be sine. Here they gave the beta value. So therefore this is the x dimension, and then positive value this is, and then y dimension is negative because downward direction, therefore negative. Okay, and then plug in the values, you will get the final velocity of the first ball along the x direction you will get. Okay. Now, the same way, we have to equate the y direction momentum also. So here, the ball is traveling along the x direction, not along the y direction. Okay. So therefore, y direction momentum is 0 for the first ball. And for the second ball, the momentum is obviously 0 because it is not at all moving. Okay. So the y direction momentum, initial momentum of along the y direction is 0. And then the final momentum, we know about the second ball's final velocity and then the direction. So plug in those values and then find out the final velocity of the first ball along the y direction. Okay, here I told you, we have to take the negative value because it is downward direction. This is the negative value we have to input, and then it is moreover sine y direction velocity along for the second ball. Okay. Now, from this we will find out the value of the first ball along the velocity of the first ball along the y direction. Now we have the two components, x component and y component velocities of the first ball. Now we have to find out the velocity. So you know v square is equal to square root of vx square plus vy square. So here we have the components, and then using these components we will find out the final velocity of the first ball. This is the value. By plugging in the values, these two values, I found out this one. And then after this, we have to find out the direction. Direction tan alpha is equal to y by x. No? So v dash 1y divided by v dash 1x. Okay. Or v1y dash divided by v1x dash. Okay. So these values, put these two values, using these two values, find out alpha. Alpha is equal to 82.2 degrees. Okay, this is the direction of the motion. Okay, now with this we found out the velocities. Next we will see whether the kinetic energy is conserved or not. Okay, now let us write the kinetic energy. What is the kinetic energy? K is equal to half mv square. So if the kinetic energy is conserved, then the collision is elastic. So let us see whether the initial kinetic energy is equal to final kinetic energy or there is any loss in the kinetic energy. If there is any loss in the kinetic energy, then the kinetic energy is not conserved, and then the collision will be inelastic. Okay, that is how we will draw the conclusion. Let us write down the initial kinetic energy. Initial kinetic energy is equal to half m1 v1 I square plus half m2 v2 I square. Plug in the values, you will get the answer as 103.75 joules. Then final kinetic energy is equal to, again the same way, you have to input the final velocities in the equation half mv square. So half m1 v1 dash square plus half m2 v2 dash square. In this, plug in the values and then find out the final kinetic energy. That will be 98.5 joules. Okay. Now, what is there is obviously by seeing these two values, we will come to a conclusion that there is some difference in the energy. That means some energy is lost because initial energy is greater than the final kinetic energy. Therefore, the energy is lost. How much energy is lost? 5.26 joules. Okay. I am subtracting these two values. I got this one. Since the kinetic energy is not conserved, the collision is inelastic. Okay. This is what he asked. See here. These are the different bits. Okay. Magnitude of the final velocity of the first mass after collision is 3.8 uh, 3.8 meters per second. Okay. 3.8 meters per second. And then the direction 82.2 degrees. Am I right? Upwards. 82.2 degrees upwards. And then energy lost. Energy lost or gained. Here energy is lost. 5.26 joules is lost. Lost. Okay. And then the collision is inelastic because energy is lost. K is not conserved. Energy lost. K is not conserved. Okay, so this is the answer for this question. Hope this helps. Thank you. Bye bye.